Okay, guys, here we go. Third new day of this unit, day 5, converting points into polar and rectangular. All right, so here's where we're going today. You guys know how to graph everything in polar, which is great now. All right, what I want to do today is if I give you sorry for my sketch here, a point on the polar grid, can you tell me what it's equal to if I plotted it on the XY grid? Okay, so here's a polar point. What would its equal be on the rectangular? All right, so this is called rectangular grid. And this is, again, as you guys know now, my polar grid. Okay, and there is not a formula, but a conversion for you. All right, and it's right here. Is that the x coordinate in the rectangular grid will be equal to the r value times the cosine of the angle in the polar grid. Because remember, every coordinate in the polar grid comes in r comma theta. So to find the x coordinate, I'm going to do the r value times the cosine of the angle. And to find the y value, I'm going to still take the r value, but now multiply it by the sine of the angle. And that should give me its rectangular coordinate. Okay? So here we go. So what I want you to do here for part A, plot the polar coordinate for me. And then we're going to convert it, and then we're going to plot the rectangular. So that's why you guys see two grids right now. You see the polar grid that we're going to plot first. We're going to convert, and then we're going to plot the rectangular down below here. Okay? So first step, get a little review in. Plotting 2 comma 3 pi over 2. All right, this was from our last topic. So 3 pi over 2, I want to get it out of 12, remember? Any radians, so I'm going to multiply everything by 6. I'm going to go through this quick. So that should be 18 pi over 12. So I got to figure out where 18 is. Remember, there's 24 total. So halfway would be 12, 13, 14, 15, 16, 17. Whoop, right here. So there's 18 pi over 12. Now I just need to go 2 units from the pole. So 1, 2, right there. Okay? So there it is. So now it's time to convert. All right, let's convert now. So to find the x coordinate, I'm going to do r cosine theta. All right, so x equals 2 times cosine 3 pi over 2. All right, so that should be equal to, now here's where I go to my calculator, and here's where you guys got to make a choice. All right, notice this angle, 3 pi over 2. What type of units is that? Is that radians or degrees? That's radians, right? So if I'm going to type all this in my calculator, it better be in radian mode, okay? Or you can convert 3 pi over 2 to degrees, but just make sure you're in degree mode. All right, whatever floats your boat here, just make sure your calculator's in the right darn mode. Okay, so I'm going to stick with radian mode here, and I'm going to ask my calculator to 2 cosine. Let's get a fraction template out. 3 pi over 2. And it says my x coordinate is 0. So that's equal to 0. Okay, so that's the x coordinate. Now we got to do the y coordinate. So here we go. The y coordinate will be equal to r sine theta. So that's going to be equal to 2 again, but now sine 3 pi over 2. So the y coordinate, here we go, back to the calc. So 2 sine, fraction template again, 3 pi over 2, negative 2. So this polar coordinate in rectangular form is 0, negative 2. That is something we should be familiar with graphing. So now I go to my grid now, my rectangular grid. Make my XY axes. And now I'm going to graph 0, -2. So 0, -2. Oh, guys, look at the two grids. They're in the same spot. All right, they're in the same spot. That's what it should be. Okay, because remember, your rectangular grid is contained in the polar grid. All right, so those are in the same exact spots. All right. Okay, one doesn't make you great. Let's keep trucking. So now part B. So this will be for part B here. It's asking us to graph -8 pi over 3. Whew, all right, here we go. So just quickly here, pi over 3, let's turn it into a denominator of 12. So multiply it by 4. So you get 4 pi over 12. So 1, 2, 3, 4 pi over 12. And now I got to go -8. Hey, -8. So remember, you're going on the opposite side now. Okay, the opposite side. So let's see. Geez, I got to go 2 away. So right here. So count out to 8. 1. I'm going right there. I always lose sight of that. 1, 2, 3, 4, 5, 6, 7, 8. Looks like I'm going to go right there. Okay? For -8, comma pi over 3. Because remember, you got to go the opposite side when it's negative. All right, let's convert now. Ready? So x equals r cosine theta. So it's going to be equal to -8 cosine pi over 3. All right, now it's all the calculators work now. So -8 cosine, fraction template, pi over 3. Okay, -4, so x equals -4. Okay, let's do the y value. Y equals r sine theta now. Y equals -8 sine pi over 3. Back to the calc. -8 sine template pi over 3. And okay, so we get a little decimal action. That's nothing to be concerned about. Okay, nothing to be concerned about. Just round it. Okay, so I'm going to say about -6.9 on that one. Okay, so my coordinate end up being -4, -6.9. Oop, get out of there. Okay, no big deal, just round it. Now graph it, and let's see what we notice. Okay, so I got -4. 1, 2, 3, 4, and down 6.9. 1, 2, 3, 4, 5, 6, and a little more. About right there. And pretty much they're in the same spot, aren't they? -4, -6.9. Okay, they're pretty much in the same spot, which usually should be a great way to check your answer, that you're graphing these and converting them correctly. They should be in the same spots. All right. Okay, next up, looks like something that I'm going to have you guys do on your own right now. Okay, so I'm going to pause my video, you pause yours, and let's come back and see if we're in the same area. We plotted them correctly, and also we converted them correctly. So go ahead, stop your video, and I'll do the same. Let's see what we can do. Let's get to work. Okay, guys, let's take a look here. Hopefully you guys noticed they fell in the same spot. The converted point should have been -1.7, comma -1. All right, hopefully we're having no issues, right? No big deal. Okay, so that's how you take a polar coordinate and convert it to a rectangular. All right, now what I want to do is just do a little review from the fall before we took the Algebra 2 Regents. What we're about to do now is going to help you in the next topic on day 7, excuse me. All right, so it's nothing to convert, no need to convert anything now. It's just going to help us convert going backwards from rectangular to polar in the next set of new notes. All right, so what I want to do first is just review real quick. It says review of finding reference angles. Real quick, just what a reference angle was. It's an angle less than 90, acute angle. It's an angle less than 90 formed by the x-axis and the terminal side. You might remember finding a bunch of these way back in the day, the reference angle. Okay, that's an angle formed by the x-axis and the terminal side. So here we go. So I have an angle of 160 degrees. Okay, again, this little b here is a Greek symbol beta. It means the same thing as theta. It's an angle measure. Okay, so it's a $1.60. So if I were to quickly sketch 160, it would be in the second quadrant, closer to 180, right? Look at that thing. Awesome. And we're going this direction. Okay. The reference angle would be this angle right here, x-axis and the terminal side, and it's got to be less than 90. So how can I determine what that angle is right there? That would be the reference angle. All right. The reference angle there. All right. So I put a little lowercase, a little subscript r with the angle beta that says, hey, the reference angle is equal to. Now, how do I find that angle? All right. If I go all the way around here, that's at 180. Okay. So if I take 180 and subtract the angle I already know, which is 160, you're at 20 degrees for your reference angle. Always reference angle is always positive, got to be less than 90. Okay. So hopefully I'm not going too quick here. We kind of remember a little bit of it. So let's go to 300 now. So if I sketch 300 real quick, make that smaller. If I sketch 300, that should be in the fourth quadrant, closer to 270. Okay, so going like this. Okay, reference angle again, x-axis, oops, x-axis, 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 and the terminal side, not the y-axis. So I'm looking for you guys to help me find that reference angle right there. Okay, the way I can find it. Now look, if I went all the way around, I'd be going 360 degrees minus the 300 I have already gone will give me what's left, which is the reference angle of 60 degrees. Okay, 60 degrees. Now, before I go on to the radians here, all right, just a little nugget. You're always going to use 180 or 360. You should never be using 90 or 270. Here's why. 90 and 270 are located on what axis, guys? 90 and 270 are located on the y-axis, and this is always on the x-axis. So you should never be using 90 or 270 in your calculations. All right, only 180 and 360. All right, moving on. Radians. Now, look, I could have you guys convert it to degrees and then do what we did for parts A and B. It takes too long. Okay, it takes too long. Okay, all you guys need to do here, quick and easy method, is take away the number in the numerator. Like what it's being, like this one's being multiplied by -5. Pi over 6, done. Oh, don't want to make sure I get the notation done. Okay, so anytime it's in radians, I can just take off whatever number is being multiplied in the numerator, and it's going to give me my reference angle, pi over 6, done. It's just easier. Could I convert it to degrees, do what I did, but then you're going to have to convert it back into radians. It's a whole ordeal for one little problem. So just take what it's being multiplied by, take it off in radians, and then take what's left as your reference angle. Okay? And then finally, what about 78 degrees? If I graph that, that would be in quadrant 1, right here. And again, take a look. What would the reference angle be? The x-axis and the terminal side. So it's 78. So if an angle's in the first quadrant, it's its own reference angle. Okay? All right, little run through that. I know that was pretty quick, but it was a little bit of a review. All right. So now I'm going to really challenge you here for these last couple, these last three. I'm going to give you what the reference angle is and the quadrant. What was the original angle we started with? Okay. So if I give you 70 degrees and I'm in quad 2. So here you go, 70-degree reference angle in quad 2. What was my, ready, I'll draw the arrow. What was my original angle, which we're calling theta here? That's what I want to know. So if I had an angle of 70, reference angle is 70, what must have been theta? All right, no big deal, right? If I went all the way around to the other side, it would be 180 degrees. That reference angle is 70, so the rest of it would be 110. All right. Again, same thing as I said above. You should be only using 180 and 360 in your calculations. 270 and 90 should never be coming up. Only 180 and 360. All right, here we go. Let's get serious now. Pi over 3 is the reference angle. In quadrant 3, you are not going to convert that to degrees. Absolutely not. We can handle this. Ready? So I got pi over 3 in the third quadrant. So that would be that angle right there, pi over 3. All right, what would it be my original angle right there? All right, let's see what we just got in this diagram now. See what we just got. Okay, when I ended right here, take a look at what I'm highlighting here, making really bold. Right here, that was what? 180 degrees, right? If I want to get the whole angle there to the green terminal side, I'm going to have to take that 180 and add on an additional pi over 3. But that looks silly, what I just wrote down. That looks pretty silly because you got 180 degrees and pi over 3 radians. Well, we've been in this unit long enough. What's 180 in radians? Pi, right? So we got pi plus pi over 3. You can handle that now. Come on, you're pros at this. Common denominator of 3. 3, so I got to multiply the pi by 3 and get 3 pi. So that angle is going to be 4 pi over 3. Boom. There you go, kids. All right, so doing the same thing. Should only be using 180 and 360 still. But now I just had to add it on. And finally, we got to give some love to quadrant 4. So what happens if my reference angle now is in quadrant 4? Okay, so that reference angle is pi over 7. How can I find my, let's get a different color, original angle in the fourth quadrant? Well, just talk to me about it in degrees first. Talk to me about it in degrees. If I went all the way around, that would be 360. So if I want to get to the red angle, I would have to subtract out pi over 7. All right, again, that doesn't make any sense because 360 is in degrees, pi over 7 is in radians. So 360, as we know from this unit, is 2 pi minus pi over 7. All right, just get common denominators, right? 7. So I got to multiply 2 pi by 7, so that's 14 pi. This pi over 7 stays the same. So my angle is going to be 13 pi over 7. Okay? So I guess that's the easiest way there to get to the angles is, do I need to add on, subtract? All right, you got to take a look at your diagram that you made. All right, I will tell you if it's easier for you, real quickly here. I don't like to have you guys memorize rules. I'd rather you see the actual idea and figure out if you're adding or subtracting. If you're in quadrant 2, it's always going to be 180 minus the reference angle. Quadrant 3 is always the 180 plus the reference angle. And in quadrant 4, it's always 360 minus the reference angle. to find the actual angle. I don't like to memorize rules, but if that helps you guys out to find the original angle, go out, get after it. All right, use whatever you need to. All right, guys, good luck on day 6, graded assignment. Take care, guys.